On to the test your understanding. Fill in the blanks to make 4 graph rules for motion graphs. You probably already have this filled in from the presentation. If you did not go through and watch all of those slides, I know it went on forever, but do that because this can get tricky. So the 4 graph rules. First of all, we have the slope of a position versus time graph is velocity. Next, we have the area of a velocity versus time graph is displacement, or your change in your position. The slope of a velocity versus time graph is acceleration. The area of an acceleration versus time graph is change in velocity. Alright, so now we are matching each position versus time graph, which is this first row, to its corresponding velocity versus time graph, which is the second row, to the acceleration versus time graph, which is the third row. So let's see how this works. We have position versus position graph. Well, I guess we'll start with 1, right? Seems like as good of a spot as any. Looks like we start off with a positive velocity, and then we approach 0 velocity. Positive velocity, approach 0. That must mean we're starting with a positive velocity and it's going down. So our velocity right in the beginning should be going down towards 0, which happens in graph C and it happens in graph E. Let's continue on. Then we have 0 velocity for some time. Sorry, graph C, you're out of here. And then finally we have the slope, which is increasing, a positive increase in this slope. So matches graph E. Now for acceleration, we have a constant negative, then a 0, then a constant positive. Constant negative, 0, constant positive. On to graph 2. 2, it looks like we start off with a 0 velocity, and then our negative velocity goes for a little bit until we hit 0 again. So we have a flat line here, and then we change directions, and we're now going farther away from our origin on our position versus time graph. So we start at 0. No, graph A, we don't start at 0. Graph B starts at 0. C, no. D, yes. So we're looking at B and D. We have a negative slope, so we have a negative velocity, negative velocity, negative velocity, and then our velocity starts slowing down until it gets to 0. Here, this is a constant negative velocity. It's not a 0 velocity. 0 velocity only happens when it passes through that origin. So it's got to be graph B. And then it's a positive after that. Alright, so if our velocity slope is negative, we're getting further towards the negative velocities. That means we have a negative acceleration to begin with. Then our acceleration switches to positive because we're getting closer to 0, and then we're getting farther away from 0. So we're approaching more and more positive velocities, so it switches to this constant line. This line doesn't change even though we pass through the origin. Direction isn't noted on your acceleration versus time graph. So if we start out with a constant negative and then we go to a longer constant positive, that is graph W. On to graph 3. 3, where are we? 3. What's happening here? We have a constant velocity until it approaches 0. Right? Constant velocity until it approaches 0. So right at about the 1 second, if that's what you want to call it, at about the 1 second mark, that's when the slowing down begins until we get to 0. Our tangent line there tells us our velocity is 0. and then we change directions. Now we're headed back towards the origin, so we're decreasing our distance. We have a negative slope, and then we're going to end with a 0 slope at the end. Looking at graph A, we have a constant positive velocity. At 1 second, it starts to slow down, right there. Starts to slow down and approach 0. Then we hit 0, true, and then we have a negative velocity, and then we start to slow down again, approach 0. So this is graph A. For the acceleration versus time graph for this, we have 0 slope, and then a negative acceleration, and then a positive acceleration. 0, negative, then positive. Position graph 3. Let's get a different color. Let's go with black. X versus time. What's happening here? We have a slowing velocity. Starts out some positive, and then it starts slowing down until it gets to 0 for an instant. And then our velocity is increasing again. We've got a positive until we get to a period of constant velocity here, and then we approach 0 again at the end. So it's constant, then it's 0, then it's positive, and then it's backwards and slowing until we end at 0. So what's left here anyway? We've done A, B, E. A, B, and E. So which one of these starts with a positive and then it slows to 0? Well, only graph C is doing that. And then the acceleration graph, what do we have left? We have Z, W, Y, Z, W, and Y. Acceleration graph. Not that we have to cross these out, but hey, why not? Let's see. I hope that you don't cross these out on your paper. Mr. Scapatis, it's too late. That's alright, you did it in pencil. No problem. Let's see. C, we have a negative acceleration because velocity is going closer to negative. Then our velocity is going closer to positives, so it's a positive acceleration, and then it's a negative acceleration. Our velocities are going closer to negative. So negative acceleration, positive acceleration, negative acceleration. Negative acceleration, positive acceleration, negative acceleration. X. And then the last graph, number 5, matches velocity graph D and acceleration graph Z, obviously, but if you want to go through it, I think that's a great idea. We start out at 0, and then instantly our slope is negative, and then we hit this period of a constant velocity, and then we approach 0 slope again, so we're slowing down, but we were in the negative, so remember that's slowing down, and then we end up in the positive velocity. We start at 0, we approach a constant velocity, so that means our velocity is not changing here.